Say we want to find the distance between 2 points. Suppose we don't know the distance formula, but we know where those 2 points are when we plot them in the Cartesian plane. We're looking for the distance between the point 1, 3 and 11, -9. And we're going to express that as an exact answer, meaning that we'll leave square roots in there if we cannot simplify in a way that leaves us without square roots. So if we didn't know the distance formula, we could put a vertical line through one of these points and a horizontal line through the other point. Take your pick, as long as whichever one you put the vertical line through, the other point has a horizontal line going through it. Then they meet at a 90-degree angle, and the hypotenuse of the right triangle would form the side that we're looking for the length of, i.e. the distance between the 2 points. The point where those 2 segments would intersect is at the point -1, -9. And our horizontal length from -1, -9 to 11, -9 would be 12 units, because only x is changing. -1 to +11, that's 12 units. Going from -9 up to +3, we also have 12 units that this is going up. And that distance we're looking for is the same as the length of the hypotenuse. 12 squared is 144. We're adding up 2 copies of that for a total of 288. Since this is a side length, we must be taking the principal square root. So square root of 288. Since that 144 was added to itself, that's the same as 2 times 144 under the square root. However, I'm going to put the perfect square part at the beginning. Apply the product rule, 4 radicals, to split up the multiplication that's underneath that square root into multiplication of separate square roots. And square root of 144 is 12. And then we can't do anything more to simplify the square root of 2. So there is our exact answer. Now remember our points. They were here's what we get plugging that into the distance formula and then simplifying. Subtracting a -1 is going to be the same as adding a +1. Here's what we have doing the addition and subtraction then. Whether it's a +12 getting squared or a -12 getting squared, we have +144 underneath the square root, added to itself, still under the square root, and then applying the square root. Based on what we learned about the connection of a square root being the same as raising something to the 1/2 power, then we have to finish what's inside parentheses basically before we can raise to the 1/2 power, i.e. take the square root. Going to become the same as what we had in the last line using the Pythagorean theorem. We wind up with 12 square root of 2. So all that's going on with the distance formula is it is taking the Pythagorean theorem and putting it in terms of the Cartesian plane, working with XY coordinates.